goal here is to be able to use formulae to find the volume of prisms, pyramids, cylinders, cones, and spheres. What we got going on here is a picture of a stylized 3D rendering of a Minecraft grass block. It takes up space. It has volume. It has capacity. Do you know how big a Minecraft block is? 1 meter by 1 meter by 1 meter, meaning that its volume is 1 cubic meter. Speaking of volume here, volume is the measure of the amount of space contained in a solid, and we measure it in cubic units. When we're talking about length, we're talking about singular linear units. How long is something? And when we're talking about area, it was square units. It was how many unit squares it would take to completely cover something. Now, volume is the number of unit cubes that would take to completely fill an object up. Okay, so when we were doing the area formulae in the axiomatic system, we used the square as the basis of all of our other formulae. The same thing is going to happen with volume, and we're going to take the cube as our axiom. So the volume of a cube is going to be side cubed. Whatever that side is, like for example, that Minecraft block, which had 1 meter on a side, 1 meter cubed, that's the size, that's the basis of all the volume that takes place in Minecraft. Okay? All right. So if we want to get the volume of a prism that's not necessarily a cube, you can use the principle of multiplication to find the number of cubes. So let's take a look at that bottom layer down there. So on this bottom layer here, it's a 2 wide and 4 long. If I wanted to count up the number of blocks, I could physically count them, but you know, it makes more sense to just use multiplication. That's 2 this way by 4 that way. There's a total of 8 cubes. And notice what I just found there was the area of the base, right? 2 by 4, it's the area of the base. Now, it has 3 layers high, right? That prism is 3 layers high, so its volume is the 8 that we got from the bottom layer multiplied times 3 layers to get 24 cubes. And that 3 there, of course, is the height in cubes for that prism. So what did we just do here? We found the volume of a prism by taking the area of the base and multiplying it times the height. In general, that's going to work for every single prism. Not only that, it's also going to work for cylinders. So what's the area of the base for a cylinder? Area of the base, well, it's a circle, which is pi r squared, right? And then we multiply it times the height. So our volume formula here is pi r squared multiplied times the height. Now, I'm going to give you a second to go ahead and read through the text on the screen here that explains the diagram and what's going on here. So you can see that in the picture over here on the left, we have ourselves a cylinder, and sort of like we did with our tortilla, chop it up into little bits, alternate those little bits, and you can see when you do, it gets closer and closer to looking like a prism, which means that its volume should be calculated exactly the same way. Area of the base, and then we multiply it times the height. So here, in conclusion, volume of prisms and cylinders, a volume of a prism, where B is the area of the base, is area of the base times the height of the prism. Okay, in the volume of a cylinder, pi r squared times the height, again, pi r squared being the area of the base, boop, and then multiplying it times the height.